Hey guys, today we're going to talk about decision tree algorithm. In this video, we will cover the basics of decision tree. We will understand how decision tree works behind the scenes. We will take a look at how decision tree splits a node. We will discuss everything in detail with the help of examples and much more. Okay, so here is a simple decision tree for you. If you want to learn about decision trees, then watch this video about decision trees until the end. And if you don't want to learn about decision trees, then click away. At the top of the tree, we either ask a question or make a statement. When a decision tree classifies things into categories, it's called as decision tree classifier. But when decision tree predicts numeric values, it's called as decision tree regressor. In this example, we consider a numeric attribute to make a decision. What is a decision tree? The objective of a decision tree is to create a training model that can be used to predict the class of target variable by learning simple decision rules inferred from its training data. Let's take an example for a decision tree.
So, I made this elaborate decision tree.
For example, we have this family with 4 members. We will ask questions such as, is the gender female? If it is true, we go to the left. If it is false, we go to the right. Then we ask another question, is the age greater than 15 years? So suppose if someone asks, who is the wife in the family? Then you can run the data down the tree and say,
keep my wife's name.
Let's now look at the terminologies associated with decision trees.
Root node.
This is called the root node because they are found at the root or the start of the tree.
A decision node.
These are called decision nodes because they have arrows pointing to them as well as arrows pointing away from them. In other words, decision nodes are the subnodes that can be further split into more subnodes.
A leaf node.
These ones in the green are called leaf nodes. They only have arrows pointing to them but no arrows pointing away from them. In other words, leaf nodes are subnodes that cannot be further split into more subnodes.
Branch.
A subsection of the tree is called as branch.
Splitting.
The process of dividing a node into further subnodes is called splitting.
Parent and child node.
Here, this is the parent node and these two are the child nodes. How to split a node in decision tree? While implementing decision tree algorithm in Python, we have to choose a splitting criteria. Mainly there are 2 splitting criteria. One is GINI and second one is entropy. Entropy ranges from 0 to 1 while GINI impurity ranges from 0 to 0.5. Let's take an example to understand splitting criteria better. Suppose we take a batch of 5 students and ask them, do you like ice cream? And they say, all of us like ice cream. Then we take another batch of 5 students and ask them, do you like ice cream? And they say, only 3 of us like ice cream. And then again we take a batch of 5 students and ask them, do you like ice cream? They say, none of us like ice cream. So in the first and last batch, they either all liked ice cream or all disliked ice cream. This is referred to as pure split. However, in the second batch we had 3 people who liked ice cream and 2 people who didn't. This is referred to as impure split because we have mixed responses from the students. This is the formula of calculating GINI impurity. Okay, here is the formula in simple terms. As per our example, in the first and last batch, we will have GINI impurity equal to 0, indicating a pure split. However, in the second batch, our GINI impurity comes out to be 0.48. Here is the formula for entropy, and here is the simplified version of it. Although both of them will give us the same result, here in case of entropy, we will have a log term which will add to more complexity. Thus, to keep things simple and running, we would use GINI impurity in the rest of the video. Information gain is used in cases where splitting criteria is equal to entropy. Information gain measures the entropy or the impurity of a random attribute before splitting versus average entropy after the split. In other words, information gain is the measure of decrease in entropy after the split. For constructing any decision tree, our aim would be to attain lowest entropy and highest information gain. Let's now jump into how decision tree algorithm works. Let's build a decision tree algorithm from scratch using this dataset. This dataset tells us whether a person eats healthy or not, whether a person exercises regularly or not. It tells the age of the person. Finally, it predicts whether a person is fit or not. At first, we want to find out how well eats healthy predicts whether a person is fit. For that, we will make a simple decision tree that only asks if someone eats healthy. For instance, in the first example, the person eats healthy but is not fit. but is not fit. Again, in the second example, the person eats healthy but is not fit. In the next example, the person does not eat healthy but is fit. We will repeat the process for rest of them and we get this. When eats healthy is equal to yes, we get 1 yes and 3 no's. And when eats healthy is equal to no, we get 2 yeses. Now considering our next feature, exercises regularly, to be at the top of the tree, computing the yeses and no's, we get this decision tree. Notice how only one leaf node contains all non-fit people. When a leaf has all yeses or all no's, it is referred to as pure split. So in this case, this leaf node is a pure split. While the other 3 leaf nodes contains mixed people, some are fit and some are not fit. Hence, they are impure split. Notice how in this tree we have both the nodes with impure split. However, in this tree we have one node with impure split and one node with a pure split. Based on that, we can say that this tree is a better decision tree. However, there is a mathematical way of quantifying the impurity of a tree. The GINI impurity. This is the formula of calculating GINI impurity. We begin by computing the GINI impurity for the left leaf, which comes out to be 0.37. Now we compute the GINI impurity for the right leaf, which comes out to be 0.44. We have got the individual GINI impurities and now need to find out the weighted average of GINI impurities. Here we take the combined probability of the whole term and multiply it with individual GINI impurities. So the GINI impurity for eats healthy comes out to be 0.4. Similarly, GINI impurity for exercises regularly comes out to be 0.21. Now we need to calculate the GINI impurity for the numeric variable. So firstly, we will sort the age column from lowest to highest value. Then calculate average age for each adjacent person. The average age for these two would be 12. Then the average age for next two will be 20.5 and so on. With all the average age values, we are ready to calculate GINI impurity for each average. So the GINI impurity for this case here is 0.42. You wanna know how? So we will firstly set the threshold as the average value. If it is yes, then we get GINI impurity equal to 0, that means pure split. If it is no, then the split is even. As we have 3 no's and 3 yes, we can proceed to calculate its impurity. If we do the maths, the impurity for the right leaf is 0.5 and the total GINI impurity for the tree would come out to be 0.429. Similarly, we will calculate the GINI impurity values for rest of the candidates. Ideally speaking, GINI value needs to be as low as possible. So we will select the lowest value among all, that is 0.34. Now we have GINI impurity for all 3 attributes. We will finally select exercises regularly as root node, as it gives best result when splitting the node. As we have already selected exercises regularly to be on root node, we would omit that column for further consideration. In the next node we get age or eats healthy as our candidates for this node. We go through the entire process again and compute GINI impurity for both of them, and at the end, let's say we get GINI impurity equal to 0 for age and GINI impurity for eats healthy. So we will again select candidate giving us minimum impurity value, that is age in this case. Now that all of our leaf nodes are pure, we can now stop splitting. The last thing remaining to do is to assign final output values to each leaf. Since all the people who don't exercise regularly are not fit, we will assign them not fit. And since the people whose age is not less than 12 years are fit, we will assign them fit. And people whose age is lesser than 12 years are not fit. So at last, this is our final decision tree. Now when a new person comes up, then we can simply run the data down our decision tree and predict the value. So yes, it is overfitting in decision trees. Now let's understand an important topic,
Overfitting in decision trees.
with reference to this example. Decision trees learns the training data in a very precise and detailed way. But we don't want to get lost in details. Rather, our aim should be to have a more generalized decision tree model. For that, let's bring back our decision tree and rewind a step back. Notice how here we are saying not fit based on only one observation. As we have so less data to be confident, our tree might have overfit the data. What do we do now? While implementing decision trees in Python, we use decision tree classifier instance, which has parameters such as min_samples_leaf and max depth. We can adjust these two parameters to solve the problem of overfitting. So with the first parameter, min samples per leaf, We can put limits on how trees will grow. Considering our example, we can set minimum samples per leaf equal to 3, indicating at least 3 people must be present in each leaf. You can see that although we don't have a pure split, we will take a decision by majority voting among them and decide. In this case, we have majority of yes votes, so final output will be fit. Now taking our second parameter, that is maximum depth. Let's look at the levels of our decision tree. This is level 0, this is level 1, and this is level 2. So currently our decision tree has maximum depth of 2. For this parameter, we need to reduce the depth of the tree by using a technique called as pruning. Pruning by definition means to cut down unnecessary branches from the tree. We set max_depth equal to 1. In this case, we cut down our branch and our decision tree would look like this. Again, with majority yes, we will assign the final output value as fit. Since all the people who don't exercise regularly are not fit, we will assign them
Not fit.